Welcome to the O-Levels. It's basically Singapore's most stressful high school exam that all the students spend 4 years in secondary school studying for. So I decided to ask myself, what if I only had 24 hours to study for an O-level subject? So I picked a subject that I'd completely forgotten, which was chemistry, which turned out to be one of the most difficult and stressful 24 hours of my life. To truly find out how much I've forgotten, I decided to try out a Sec 4 prelim paper, and well, I don't know how to say this, but I realized that I kinda almost forgot everything. Electrons over here. 1, 2... I'm just gonna copy how they did it over here. What is this? Identify the unknown substances. The Cl, I believe, will go to here, and then the H will go to here, right? So gas U is definitely hydrogen, right? Hydrogen. This is gonna go on a wild guess, and we're gonna say electrolysis, because that sounds right. This reminds me of when the Try Guys went from 4 to 3. Because each carbon has 3 bonds. Because here, right, there's 1, 2, 3, and here there's also 1, 2, 3. Okay, I think that's it. So, to figure out truly how badly I did, I decided to call in someone who actually knows and teaches chemistry to mark this mess and help me form my study game plan.
This is Yao from Vantage Tutor. Most of you already know me from TikTok, from talking about chemistry. I'm a tutor for a while now, and most of the time, I'm teaching secondary school students and JC students.
So, how did I do for the first Pasir Ris prelim paper?
Nothing short of a disaster. I could see that effort was put in. I could see that you have remnants of what you learned in secondary school. One good thing about what I learned from marking your paper is there is a clear theme in what you're lacking. I'm going to go from this theme, then from there into different topics.
Okay, a score of 17 out of 80 isn't great, but hey, at least we managed to score double digits, okay? And officially, the 24-hour challenge has begun. So we basically went through the misconceptions that I had, and also Yao teaching me tons of new stuff that I have no clue even existed, or maybe I just forgotten over the years. At the end of the teaching session, what I thought was super helpful was when we broke down the topics that I needed to study into Bundle 1 and Bundle 2. Then we went over the syllabus document, and Yao basically kind of laid out the important points of what I need to know for each topic. Then we said our goodbyes, and I was on my own for the rest of the challenge. So let me present to you my topics game plan. We're gonna categorize each topic into one of 3 tiers. The must-do tier, which consists of my strongest topics, where I'm aiming for close to full credit. The just try our best tier, where we're just gonna study what we can and hope for the best. And lastly, the GG go next tier, which I'm basically giving up and not studying these topics at all. In the must-do tier, we have atomic structure, mole concept, periodicity, and energetics. A special shout out in the must-do tier also goes to anything that has some sort of calculation, table, or graph, because I'm trying to leverage on my math skills, you know. In the just try our best tier, it's the main bulk of all the topics, so we have experimental chemistry, chemical reactions, acid, base, and salts, and lastly we have air and atmosphere. In the GG Go Next tier, we basically decided to skip through the whole of electrolysis and organic chemistry. Even though this was the original plan here, you'll see later on that we had to change up our strategy a little bit. If there was one thing I learned during university, it was cramming large amounts of information the night before the exam. So after eating some lunch and scrolling through YouTube for a while, I had to lock in for the next few hours because it's the most important part of this challenge. I call it the constructing knowledge phase, where I'm trying to understand as many new concepts as possible and drawing relevance to the things that I already know. So, we're not going to waste any time by making notes for each chapter because we only have 24 hours. So here's my studying strategy. We're going to go straight into practicing more prelim papers. To save even more time, and since I don't need to review this information after the challenge, I sort of mentally try out the question in my head. Then I take a look at the answer key and only write down stuff that I got wrong or the key information that I want to remember. If I still don't understand how it's done by looking at the answer, that's where I gotta bridge the knowledge gap. I first identify which topic it is and point it out in the syllabus document, and I'm not joking when I say this, but ChatGPT is actually an amazing studying tool. I asked ChatGPT to basically teach me that specific point, and if I still don't get it, I just ask it the question and compare the response to the answer key to bridge the knowledge gap. Okay, next is all about identifying key concepts. So for the topic on atomic structure, I needed to follow a 3-step formula to identify the type of structure held by what kind of forces of attraction, and something about the energy required to overcome them. So I just needed to memorize this and match them. Another one that seems to be in every calculation question, no matter what topic it was that it required me to calculate the MR of the compound and use it somehow in the calculation. So that will always be my first step. The first prelim paper that I went through was from Fuhua Secondary, and it was great. The questions were surprisingly super well designed to teach me things that I didn't know. Okay, for example, this question A4 here taught me the whole idea of the reactivity series and how it's applied. A6 basically taught me everything about the 3 methods of salt preparation. Also, I didn't know if I was going a little bit crazy at this point of the challenge, but I felt like doing chemistry was kind of like playing Pokemon. I mean, if you think about it, you have 150-ish Pokemon and about 100 plus elements in the periodic table. I was learning new things about some of the elements that I didn't even know about. Like, for example, copper can exist as a +1 charge or a +2 charge because it's a transition metal. So it's one of those special species of Pokemon. You know, like one of those evolutions that have a branching path like Slowpoke being able to evolve into Slowbro or Slowking, or the entire evolutions line. But okay, that would be a pretty crazy element if it existed, being able to exist in like 5 different charge states at once.
It's 6 hours into the challenge and we got ourselves a matcha cake from Chatteray's. Oh, look at that. Perfect bite. The paper I just did, there was a 4-mark question on preparing a certain different amounts of salts, a different type of salts, and I had no clue what is going on. I don't even know what plus what equals to what.
So after that little cake break, the second paper I tried was from CHIJ St. Nicholas, and this was the paper that really shook my confidence. This paper was so difficult. I was seriously questioning if this challenge was even possible. Okay, for example, at this point I had quite a bit of practice in writing an ionic equation, but when this question asked about it, I had absolutely no idea how to even start, even looking at the answer key. Many of the questions in the must-do tier, I can't even start on them because there was just information that I didn't know. Like for this question, I couldn't start on the mole calculation part because I didn't know iron was Fe2O3 and I didn't know whatever this reaction was, so I couldn't even start on the question. To make things even worse, I realized that there was another chapter that I have to add to the GG Go Next tier, which was QA. It's basically a huge table of reactions where you gotta memorize what colors it forms, and ain't nobody got time for that, especially if you only have 24 hours. And I realized it was a huge bottleneck in many of the questions where they ask you to identify things because of the color change from the QA table. It was at this point of the challenge where I realized I needed to do 2 things. Number 1, I needed to change up my game plan, and number 2, I needed someone to clarify my doubts with. When I was doing the prelim papers, I went to count the percentage of marks in our GG Go Next tier, and they made up for about 35% of the entire paper, and I don't think my other topics are good enough to make up for that deficit. I simply just couldn't throw away 35% of the exam. So here's the solution that I came up with. We're gonna rename this GG Go Next tier to something we call the one and dones. I'm basically trying to find some small isolated chunks from these chapters where I can memorize and gain some credit. It's a term from like Valorant where you can get 1 kill and then you're dead. Even though we don't understand the topic at all, we're gonna look for the few parts that we did prepare for, complete them, and then we give up on the rest. So for electrolysis, I prepared on the difference between a simple cell and a chemical cell, and also the section on sacrificial metals, which I think is the easiest part of electrolysis. Also, I kinda did it for the memes, because did you know that steel that has a protective zinc coating is called galvanized steel, and that's where the galvanized square steel meme comes from? So that's how my brain remembers things, I guess, through memes and analogies. Since we're on the topic of analogies, let me give you another analogy I use to remember limiting reagents. It's kind of like crafting in Minecraft. So to make a set of 4 torches, you need 1 stick and 1 coal. But if you had 10 coal and only 1 stick, You still can only make 4 torches because the stick is the limiting reagent. Okay, let's go back to our strategy. I needed someone to work out the one and dones for organic chemistry, because organic looked worse than trying to read the Minecraft enchantment table language. So I called in my good friend on Discord, who's an absolute chemistry genius by the way, to teach me a bit of organic chem and some other topics.
To understand organic chem, you have to understand the 4 functional groups in your syllabus. Let's be a bit more systematic here. We have to write down what all these bullet points can react with, then we can start cooking. Oh, that's the carboxylic acid functional group, actually.
Is it
yeah, that's why I react with carbonate, because it's an acid. Yeah, if the OH is bonded to a C that's also double bonded to an O, it's not an alcohol functional group, it's the COH functional group.
Oh, yeah. So you can't use it
So that one actually won't react with manganate. The 2 carbons are holding hands. Then when you do the polymerization, they let go one of their hands and they fan it out.
I get it. So,
yeah, chloride. So since it's the positive test for chloride, you deduce that T contains both iron 2 and chlorine. So what would this?
So it's iron.
So what would the chemical?
Chloride.
Yeah, that's right.
Wow, this is a very difficult 1 mark to get.
Okay, sure.
Such as the likely identities, cations and anions.
Okay, this is technically true, but like. Fantastic, yeah, that's the ionic equation. It's just the regular one, but you remove potassium because it's not doing anything.
So the parts of organic chem that we prepared for was unsaturated versus saturated and how it links to the different functional groups, and also briefly on addition polymerization. Now I'm gonna let you in on a secret part of my strategy, which I call the cheese strats. It's basically trying to gain credit for questions in an unintended way by finding ways to exploit the question, sorta like abusing a bug in a game. Now, real talk. If you're an O-level student watching this, I really don't recommend these strats if you have the time to study and actually understand chemistry. But for me, desperate times call for desperate measures. So let me show you a few examples. I quickly noticed that the electrolysis questions love to ask you about what you can observe in the 2 electrodes. And when I was studying different papers, they all seem to have the same solution, where effervescence occurs at the anode and a reddish-brown solid coats the cathode. Now you might be asking, how do you know which one is the anode and which one is the cathode? And my answer is, I have no clue. If you thought that the 50-50 in Genshin was bad, I call this the anode-cathode 50-50. But for real, for something that you can pre-memorize, a 50% chance of getting 2 marks seems pretty worth it to me. The next one is drawing the energy profile for the exothermic and endothermic reactions, which look like this and like this. Now, usually you have to read the question and figure out whether the reaction is exothermic or endothermic. But do you notice something strange about the starting line for these 2 questions? For this question over here, the starting line is way too high up for the reaction to be endothermic, so it has to be exothermic and goes down. And for this one, even though the difference is not so huge, the setter kind of moved the line a little bit down to suggest that the reaction might be endothermic. So we're kind of cheating by looking at the position where they draw the line instead of whatever reaction is going on. At this point, I've been studying for like 12 hours and I was incredibly tired. I decided to stop doing any more papers and to review what I learned. There was just so much to memorize, and I don't know how to say this, but I felt stressed. I knew it's just a challenge, but there's that feeling of having an exam the next day and you feel like you have no idea what's going on. I suddenly felt this urge to want to pass because I didn't want to let down the people who spent their time teaching me throughout the challenge. Before I went to bed, I decided to use the oldest trick in the book that I learned from university, which was watching lectures at 2 times speed. I found this O-level chemistry playlist on YouTube by Bernard Ng, and it was so good. My plan was just to consolidate the things that I knew and go through the syllabus document again as sort of like a mental checklist, and lastly to let go of the things that I know that I can't understand in time, and finally to trust in my strategy. So I woke up the next day, had my morning coffee, and it was time for the final test. Could I really pass the O-level specimen paper with only 24 hours of studying? The good news is that on first glance there were some questions I knew I had it in the bag. Like for example the mole calculation questions and periodicity questions. But the bad news was that atomic structure, which I studied so much for and it's probably my best topic, didn't come out at all. Like I was so ready to talk about them electrostatic and intermolecular forces and draw the dot and cross diagrams, but none of that came out. But I still had to try my best. And is the most abundant gas? That's nitrogen. Okay, the first question is pretty good. Okay, we're good. Whew. I thought I almost threw that one. Okay. Oh no, wait, I remember this. This is the isotopes, but I kind of forgot. Whoa, okay, I don't know anything about this one. Okay, what is this? What is this? Okay, never mind, we don't worry about that first. Hydrogen is used to make margarine from vegetable. Whoa, margarine? Like, oh! Okay, I studied for this. Oh my goodness, wait, I have to get this redox reaction right. I studied so much for redox. I've seen ethanol in real life, I think. Yeah, because the boiling point is 78. Okay, great. Another thing I learned over the years of doing mini exams is about trying to make an educated guess if you don't know. For this question, I did not study for this at all, so I had no idea what A, B, C, D, and E are. But I sort of figured there's a reason why A is at the top, because it kind of floats up. So I guess that it's the least dense and E is the most dense. And I guess that the first two parts will make use of these extreme values, so the answer is either A or E. Okay, one last example. I had no clue what these numbers beside the element means, and because it's so similar to the periodic table, I kinda guessed that this was the number of protons, and this was protons plus neutrons. But if I was truly a 200 IQ guesser, I would have figured out that this can't be the case, because 1 minus 2 will give us -1 neutrons for this isotope here, so it must be in the reverse order. But anyways, I did what I could, and my time was up. So I sent it over to Yaola to mark, and all I could do was wait.
So after spending about an hour marking through this paper and trying to be as fair as I can, these are the scores that you have achieved in this paper. And that comes up to a total of 59 out of 80. This is a huge improvement. You can see that whatever we spoke about in terms of mole concept, in terms of your oxidation state, so congratulations. I think this challenge is a success. This is Yaola from Vantage Tutor, a class above the rest.
Let's go! A result of 73% was just absolutely crazy, and I was just so happy, and it's not even my real O-level results. I have to say that the data analysis question was pretty forgiving compared to the first test, like what even is this triester? But for this paper, as long as you can get past the reading, they kinda teach you about all 3 chromatography tests. So basically, if you're not colorblind, you know how to read a COVID test, and you know how to read a heart rate monitor, you can do this question. I was also quite lucky that this paper had a lot of calculation questions, which I loved, and the either or question, let me tell you, I had the easiest choice of my life because the first question literally had all the concepts that I was confident in. Also, Yaola did give me the benefit of doubt in a few questions here and there, so So yeah, it's never too late to start studying, even with just 24 hours. I actually noticed a significant improvement in my understanding of chemistry while I was doing the O-level specimen paper. But would I recommend cramming everything the night before O-levels? Probably not. Take care everyone, Axolotl out.